Hello students. In this session, we shall discuss about how to find geometrical isomers. How to find geometrical isomers. So in general, geometrical isomers are two types. Okay, mainly cis isomer and trans isomer. Cis and trans. It is two types geometrical isomerism. So here cis isomer is what? Generally when ligands are arranged uh, at the same side with respect to each other, then it is called cis isomer. ఒక cis isomer అంటే ఒక సెంట్రల్ మెటల్ ఆటమ్ చుట్టూ మనం జనరల్ గా వాటిని ఆటమ్స్ ని అరేంజ్ చేస్తాం కదా. సో అలా అరేంజ్ చేసినప్పుడు ఏవైనా రెండు సేమ్ ఐటమ్స్ ఒకటే సైడ్ వస్తే దాన్ని సిస్ ఐసోమర్ అంటారు. ఒకవేళ ఆ ఆటమ్స్ అనేవి అపోజిట్ సైడ్ లో వస్తే దాన్ని ట్రాన్స్ ఐసోమర్ అంటారు. ఓకే, సో సిస్ ఐసోమర్ మీన్స్ ఆటమ్స్ ఆర్ ligands. Generally those are called ligands occupy same position with respect to each other. So trans means what? Ligands occupy opposite positions with respect to each other. సో ఫర్ ఎగ్జాంపుల్ సిస్ ఐసోమర్ కి మనకు ఎగ్జాంపుల్ తీసుకుంటే సెంట్రల్ మెటల్ ఆటమ్ ఉంది. సో మెటల్ ఆటమ్ చుట్టూ ఇక్కడ ఏ ఉంది అనుకోండి. సో ఈ సైడ్ కూడా ఏనే ఉంది, ఇంకో సైడ్ బి ఉంది, అండ్ ఈ సైడ్ కూడా బీనే ఉంది. సో ఇప్పుడు ఏ అండ్ ఏ బోత్ ఆర్ ప్రెసెంట్ ఎట్ సేమ్ సైడ్, ఆర్ బి అండ్ బి both are present at same side. So here A and B, these two also present at same side, and here AB also present at same side. So this type of isomer is called cis isomer. Then what is trans isomer? If these ligands are opposite to each other. B. So now here AB and AB both are different ligands present opposite to each other. Here A and A both are perpendicular to each other, and B and B both are perpendicular to each other. So this type of isomers are called trans isomers. So how do you find cis isomer and trans isomer when a coordination compounds are given? Because different coordination numbers are there. In general, coordination number 4 and coordination number 6 mainly. So how do you find number of geometrical isomers in case of coordination number 4? So let us discuss. If coordination number 4 is given, we are discussing for coordination number 4. Coordination number 4 వస్తే ఎట్లా ఐడెంటిఫై చేయాలి? సో కోఆర్డినేషన్ నంబర్ 4 వస్తే, అంటే ఫర్ ఎగ్జాంపుల్ కోఆర్డినేషన్ నంబర్ 4 అంటే COCl4. So here coordination number of metal atom is 4. Okay, so coordination number is what? Generally the number of atoms that are surrounded by central metal atom. So our central metal atom surrounded by ligands with respect to each other. So here coordination number of cobalt is 4. So in general, in this type of ligands, how these ligands are arranged around the central metal atom. And in case of coordination number 4, there is another example. So that is Square planar. So this is called square planar complexes. Square planar, and this is tetrahedral geometry. Square planar geometry, tetrahedral geometry. Two types are there. When coordination number 4, in case of coordination number 4, two types of compounds are possible. One is tetrahedral. Let us discuss about tetrahedral geometry. So in tetrahedral geometry, the molecule structure will be, so here bond angle is generally 109 degrees, 28 minutes will be there. So if you rotate any one of these ligands around central metal atom, geometry will not be changing. So we will not be getting any geometrical isomers. There is no variation, there is no difference in the structure. Understand? So this type of coordination compounds does not have any geometrical isomer. So geometrical isomerism not possible for tetrahedral complexes. Understand, students? Geometrical isomers are not possible for tetrahedral coordination complexes. Generally, in this type of compounds, hybridization will be sp3. In this type of also sp3 will be there, hybridization. So let me tell you some examples based on square planar complexes. In case of square planar complexes, there are several arrangements. Okay, these ligands can be arranged in different ways. So I can take here monodentate ligands and bidentate ligands. So there are many ways to take the ligands around the central metal atom. So how many types are there? We shall discuss one by one. The first two types. For square planar complexes, coordination number 4. So type 1, Ma2, B2, Ma2, B2. So in this type, so these ligands can be arranged in two ways. One is AA, BB, this is one arrangement, then AB and AB, this is another arrangement. So totally we will be getting geometrical isomers 2 only. So రెండు మాత్రమే వస్తాయి ఇందులో. So for example, I will give you an example: platinum NH32 Cl2, diamine dichloroplatinum. So here platinum is the central metal atom, platinum, then NH3, and here NH3 Cl, Cl, and one more PT, NH3, 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 Cl, and Cl. This is another arrangement. So usually when same ligands are present at same position, that is called cis isomer, and when the two are opposite to each other or perpendicular to each other, so this is called trans, and this is called what? Cis. This is trans isomer. So next, another type, type 2. So type 2, Ma2Bc. Ma2Bc. So in Ma2Bc type, so usually what we can get here, how many types we will get? We will be getting geometrical isomers 2 only in this case also. For example, platinum NH3 Cl Br. So this is one type of coordination compound for the given example. So here central metal atom is platinum, then Cl and Br, both can be written opposite sides. Then NH3 and NH3 can be written opposite side. So if the same ligands are opposite to each other, that is called trans isomer. దాన్ని ట్రాన్స్ ఐసోమర్ అంటారు. సో దీనికి సిస్ ఐసోమర్ ఎలా రాయొచ్చు? ప్లాటినం ఈ సేమ్ NH3 అండ్ NH3 లైగాండ్స్ ని సేమ్ సైడ్ రాసుకోవచ్చు. సో ఇది ఒక పాసిబుల్ అరేంజ్మెంట్ ClBr. సో దిస్ ఇస్ కాల్డ్ వాట్? సిస్ ఐసోమర్. సో నెక్స్ట్ అనదర్ type 3. M, A, B, C, D. This is another type. Coordination number 4. Third type M, A, B, C, D. So how many types we can, how many ways we can arrange these ligands? A, B, C, D, like this we can arrange, or A, C, B, D we can arrange, and one more type A, D and BC. We can arrange it 3 ways. Understand? So total geometrical isomers are 3 in this case. So geometrical, I will give you an example in this case. Example. So we can take 4 different ligands: platinum, pyridine, nitro group, then Cl and NH3. So 4 different types of ligands we can take here: A, B, C, D. Then how do you arrange these types? Platinum. So you can fix one ligand, then remaining ligands can be rotated, or you can flip the remaining ligands. One ligand you can take as standard one. So if you fix this ligand, so remaining positions you can flip around the central metal atom. So if you flip these two ligands, then what you get here? NO2 you will get here, then Cl you will get here. So pyridine will be same position, and NH3 also same position. So if you fix this position again, if you rotate these two ligands, this one and this one, you will get one more isomer, NH3. Here NO2 will be there, and here pyridine, and also this one Cl. So this is another type. So total what we are getting here? 3 isomers, geometrical isomers, 3 in this case. Very important, students. So next type 4. Next type 4. Type 4 MAB2. MAB2. MAB2 means here AB is a bidentate ligand. Bidentate ligand. So geometrical isomers are 2 for this compound. Geometrical isomers 2 only possible. So geometrical isomers 2. I can give you an example. In this case, దీనిలో మనం ఒక example తీసుకోవచ్చు. So glycinate of bisglycinate of platinum we can take in this case. So how do you write the structure for this compound? So platinum is the central metal atom. So glycinate NH2 CH2, then C double bond O, then O minus. The next one here O minus, C double bond O, then CH2, NH2. So this is one of the ways, 2 ways. And the second way, platinum, this O minus can be taken opposite side, then again CH2 and NH2. And here this one should be taken same side, C double bond O, then CH2 and NH2. So this is another possible. So this is called trans isomer, and this is called cis isomer. So these two structural arrangements are same side, it is called cis. So if these are opposite to each other, then it is called trans, perpendicular to each other. So this is another type 4. Next we shall discuss for type 5. Type 5. So fifth type, what we can take? M, A, B, C, D we can take. Here C, D both are monodentate ligands, mono. Then AB is a bidentate ligand. Okay. bidentate and monodentate. So for example, in this case also geometrical isomers 2 are possible. Geometrical isomers 2 are possible in this case. For example, platinum, here bromine and a nitro group you can take, and another side only bidentate ligand you can take, C double bond O, then CH2 and NH2. So this is called what? One of the two isomers. Next, platinum NO2 and Br O minus, C double bond O, then CH2 and NH2. This is another isomer. So, okay, students, so these two are different isomers. Two isomers are possible in this case. Next, another type 6. Type 6, MA4 type. MA4 type. So how do you write in this case MA4? Suppose central metal atom, all are same ligands only. If you flip these two ligands or rotate these two ligands around the central metal atom, you will get same geometrical arrangement only. So in this case, geometrical isomerism not possible. So 0 for this case. Next to type 7. Seventh type MA3B. MA3B. So in this case, MA3B, three ligands are similar. M, B, and remaining three are similar. So if you flip these two iso ligands, we will get same geometrical arrangement. So in this case also geometrical isomers are 2. If you rotate these two isomer ligands, then you will get same arrangement. So that is why in this case geometrical isomerism 0. Isomers are 0. And last type MAA2. MAA2. AA means here bidentate ligands. Same type of ligands, bidentate. So in this case, for example, central metal atom A and A, this is bidentate, and here it is A, and it is also bidentate. If you flip these two ligands with respect to each other, you will get same uh, arrangement. So in this case also geometrical isomers are 0. Okay, geometrical isomers are 0, and final type we will get another type MAAB2. Okay, AA are bidentate ligand. It is a bidentate ligand. So this one. So in this case, how do you represent the molecules? BB same side and A another side. So this is bidentate ligand and these are monodentate ligands. Monodentate. So if you flip these two ligands opposite to each other or with respect to each other, you will get same arrangement. So in this case also geometrical isomers are 0. So students, okay, this is the simple trick. These are the simple tricks to find out geometrical isomers. If you like the video, just press the like button. And if you want more content like this, just subscribe to our channel for more latest updates. Thank you for watching.